Hello there, I'm Thomas Hatsios, German-American pilot flying the Boeing 787-900 tonight's flight. We're going to be overflying Zurich, Switzerland, Germany, then coming back to the Zurich International Airport, the runway 14 for an Ilsloc localizer landing, surrounding the cockpit for the pre-takeoff preparation of the quality wings, Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing the cockpit instruments, the displays, and the functions of the Boeing 787-900 jet aircraft. I'm going to start with the primary flight display. That displays the airspeed indicated, the airspeed selected from the autopilot, the flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot and flight director system panel, the barometric pressure of the outside atmosphere, the radio altitude selected also, and the minimum altitude, and also the altitude indicator of the pitch ladder decrease, the bank angle increase, the artificial horizon. We have the ILS localizer, the horizontal localizer, the vertical glide slope, the receivers of the onboard antennas of the aircraft that receive the radio frequency transmitted from the threshold antennas of the runways we use for takeoff and for landing, which help us to align the aircraft with the runway heading, the localizer, and also the elevation above the runway as we approach for landing, the glide slope in degrees. So we have the runway 14 of Zurich International Airport, Lszh in Switzerland. So we're gonna use the ILS localizer frequency. You will see displayed in the primary flight display. We have also the angle of attack of the aircraft as it flies in the flight mode done at 0 with the autopilot and the autothrottle. Later our vertical navigation mode. We have also the vertical rate of climb descent of the aircraft, or the VSI vertical speed indicator. That displays how fast the aircraft climbs and descends, or the thickness of the trigonometric angle to decrease. Also you can set from the flight path angle degrees in the autopilot flight director system panels. Also you the modes you can use. You can see also we have the SSI, the horizontal situation indicator, that displays the magnetic heading and track, and the standby the degraded flight plan display. So we're gonna create a flight plan using the flight management computer. You're gonna see later how I'm gonna use the flight management computer to input all the data of this aircraft for this flight. So you will see the flight plan displayed with a purple or magenta line with the stars, the waypoints we're gonna use to fly through the flight plan legs. So you will see we have the navigation display. The navigation display that displays the horizontal and vertical profile of the aircraft as it flies. You can see the terrain and weather reflections from the weather radar, the horizontal and vertical. So we have here also, as you can see, the red, green, yellow color indication of the terrain around you in the navigation display. You can see how far above the ground you will be flying. If you look in the vertical deviation display, the vertical profile over here, so we have the horizontal profile over here of the aircraft, the terrain map, the airports. You can see our own airport, how far above the ground we will be flying. Later you will see also the flight plan in the vertical display. You can see also the airspeed, the barometric altitude over here. So this is the airspeed indicator, very important. The airspeed selected from the autopilot flight director system panel, the altitude selected right now, the barometric altitude above the sea level, vertical rate of climb descent, the pitch ladder in degrees, 2.5, 5, 7.5, 10, 12, 15, 17.5, 20 for pitch up or pitch down. Also the bank angle in degrees when we make turns. You can see the radio altitude. We are minus 2 feet above the ground right now, as displayed here. So you can see also the barometric pressure over here, 29.92 inches of mercury. So we'll set, we have the magnetic heading also here, 360 degrees. So you can set over here. You can set the barometric pressure in inches of mercury or hectopascals over here, the baro radio minimums, the plan range, weather radar over here, traffic and terrain on the display over here, the navigation display. Also, so this is the primary flight display. You can see also the flight mode annunciator in the top part. That displays the auto throttle mode, autopilot, flight director, and auto throttle right now. So you can see flight director also displayed. So you can see the 200 knots of airspeed right here. 200 knots over here. The airspeed selected from the autopilot, flight director system panel. Autopilot engage, disengage, flight director engage, disengage. The speed, flight level change. Auto throttle, climb, continuous speed, LNAV and VNAV, which are interconnected to the flight mode flight management computer, and the auto throttle left and right arm and disarm, so you can see indicated airspeed or Mach speed later. Autopilot here disengage, AP disengage, heading select, and vertical rate of climb descent of the aircraft, you will see later. Altitude select over here. So I will show you the details of the instruments of the aircraft before we go into flight. You can see here we have also the mouse pad of the aircraft that we can use for controlling the flight management computers over here. So you input all the data you need using the touch screen here. Then you can control the flight management computer over here. As you can see, you'll see the purple modes selected, the purple box as we shift up and down the selection of the touch screen here. We have also we're gonna create a flight plan using the keyboard selection over here, just for numeric keyboard. So you will see here how we're gonna create a flight plan. So you will see the flight plan displayed, the navigation display here. The navigation display that displays also, as you can see, the terrain and weather reflection from the weather radar, red, green, yellow, blue for the sea, the lakes and the rivers. You can see the terrain map with the airports, 4-letter name, airport code, our own airport, our own runway and taxiway. From the GPS you will see we can navigate the aircraft with the GPS and the terrain map, the magnetic North Pole and geographic North Pole and magnetic variation depending where we are in the world. You can see the range in nautical miles, how far away the other airports are, the voice stations, the ADVs, the NDBs, the navigation aids that we have, the waypoints which are horizontal and vertical navigation fixes the aircraft we're going to have to transverse through in every flight, in this flight also. So you'll see how I'm going to select later in the flight management computer. I'm going to use also, I will show you all the instruments of the aircraft. So you'll see in the navigation display also we have the wind direction and speed also in the HSI and the vector of the wind when we flying. You can see other aircraft that fly around our own aircraft using the transponder that is being an AC transmitter receiver that transmits our frequency to other aircraft in the air traffic control tower, so you can also receive from other aircraft and display. You can calculate using its computer the other aircraft distance from our aircraft, altitude difference from our aircraft, how many feet above or below are, and whether they climb or descend with respect to our aircraft. You can also calculate the velocity closing in between our aircraft and the other aircraft, so it will give us a warning if we have an incoming collision in the air. The TICA system, the traffic collision advisory system of the aircraft using the transporter. The transporter is over here, as you can see. Transporter mode over here. In the radio management panel you can see also we have the display of the navigation radios over here, VHF, HF, SAT, satellite, cabin, ground proximity warning, weather radar, transporter. So you can select also the navigation ILS localizer. So this is radio management panel. You can see also we have the radar trim here, the fire extinguishers for the left and right engine, the fuel flow to the left and right engine, the thrust levers. Over here we can move the thrust, increase and decrease the engine indications you will see here. So this is how you control the thrust. Over here you will see the N1 increase when we add some power in the engines. So we're not configured for takeoff right now, as you will see. It will give us a message, a warning here with red. That we should not use the takeoff power. So we have the brakes also on. You can see, so we don't move when we add power right now. So you can arm and disarm the brakes here. As you can see, we have the horizontal trim stabilizer, alternate pit trim cutoff switch for the manual trim switch. So this is the cutoff for the auto trim system. I will start showing you the controls in a couple of minutes of the aircraft. I will show you also the flight controls. So you will see with the flight controls what I can do. You can see also the other displays over here. The other side, the first officer displays. You can see again the airports that I'm telling you about, how far away you look in the GPS. All these letters are airports. So you can see also the terrain over here if you need. So you will look here further away. You will see also here more congested airports. So now you can see here is Germany, here is France, and here is Switzerland, where we are located. So I will show you also the flight controls of the aircraft. I use the side stick velocity to control the aircraft flight controls, the Boeing 787-900. The aircraft, the yoke for climb and descent over here, as you can see, for making turns left and right. So maybe I'll show you also the screen with a better view. So you can see we can use the flight controls over here. I use the side stick, and this commands the yoke for movement. So we can climb and we can descend using the elevator over here. So this is the elevator control for climb and for descent over here. The rudder control for making left and right yawing turns, also the ailerons and the spoilers over here. So I will talk to you about also the flight controls, the rudder pedals, what they control. You will see the flaps and the slats, the speed brakes of the aircraft. So I have the control of the side stick here. I will talk to you also about the Newton's physics, aeronautical and aerospace engineering, Bernoulli theory of fluids, Newton's physics and aerodynamics. So we need to know some principles before going into flight. I will show you the aircraft and what I mean by that on the outside view. So you will see here now. So you will see here we have the outside view. You can see the wings of the aircraft. The surface area of the wings holds the aircraft weight as we fly. We have the thrust propulsion from the engines, the jet blast that moves the aircraft forward over here through the engines exhaust nozzles. We have also, so this is the vectors of the thrust from the engines. We have the mean aerodynamic chord position here, the Mach, which is the mean aerodynamic chord where the maximum aerodynamic lift occurs in the wings. Is 23% of the mean aerodynamic chord of this aircraft. Is where the maximum aerodynamic lift occurs in the forward wings. Is also the position where the stall will begin, the airflow will become detached all the way back when we fly for a given angle of attack and an airspeed that is changing. You can see also here we have the center of pressure in the top of the aircraft. It moves forward and after when we fly. We have the center of gravity, it transverses here, which is the yawing axis, the center of gravity. So the yawing axis of the aircraft, the rudder axis, as you can see, for making left to right turns like this, we use the rudder pedals. So this is the yawing axis of the aircraft. We have the longitudinal axis from nose to tail, which is the roll axis, so you can make turns left and right when flying using the rolling axis of the aircraft. The ailerons and the spoilers like this. As you can see, one wing at a time, left or right turn, ailerons and spoilers like this. So this is the rolling axis. This is also the lateral axis from wingtip to wingtip. Is for the pitch axis for the elevator, for making climbs and descents of the aircraft like this. So you can climb and you can descend like this. So you climb, use the elevator up. You descend, move the elevator down, the yoke down. So this is the flight control's main explanation, the aerodynamic of the aircraft. So we have also, as you can see, the horizontal trim stabilizer. For the horizontal stabilizer of the elevator of the aircraft, as we fly, we can also trim, use this trim switch over here, and this will move the aircraft elevator or horizontal stabilizer up and down as we fly to balance the aircraft. So use this trim switch over here to trim the horizontal elevator of the aircraft. I will show you in a couple of minutes. So you can see also we have the bottom surface of the wings is more flat using the Bernoulli theory of fluids. Also we have the extended flap, and also we have when we fly in the aircraft we'll be having an angle of attack that is positive most of the time. So then we're gonna have a lower airspeed below the wings. Using Bernoulli theory of fluids is gonna give us higher pressure below the wings, which is gonna pressurize the aircraft wings and weight up into the air. So also when you see the top surface of the wings has a more curvature, is more curved. So using Bernoulli air fluids, the airflow is moving much faster above the wings, so we're gonna be having a lower pressure, which is gonna suck the aircraft weight and wings up into the air. So this is the basic principles, the aerodynamics, as you can see. Flight controls here for climate descent. So also you also flight controls inside. The horizontal trim stabilizer also. So we use the flight controls, as you can see, surfaces. We can move the elevator for climb and descent, the ailerons and the spoilers, the control wheel for making left and right turns. Also we have the elevator, the control column of the yoke. We have also the rudder pedals for the yawing turns, the rudder. Also in the rudder pedals we have the nose wheel steering the ground and the toe brakes. So you can see the nose wheel steering also. We have the tiller and the rudder pedals, so they are interconnected at about from 0 to about 76 knots. The deflection decreases of the nose wheel of the tiller from 76 degrees to like 7 degrees at about 45 knots at takeoff. Then it decreases to 0 at about 70 knots. Then you have only the rudder pedals. They're also interconnected, the rudder pedals and tiller. So you have also you have the rudder is aerodynamically effective at about 45 knots in takeoff. You can see the rudder here for making yawing turns, ailerons and spoilers. Also very important bank roll turns. And the elevator, as you can see, the elevator for climb, for descent, making turns to the right, control wheel. This is the control wheel. You can use either one, only the control wheel, only the elevator, only the rudder pedals, whatever you need, all together. You can see also the captain and the first officer are interconnected and move together in flight unless you have a failure. They're not like in the Airbus, you have the side stick priority. Also this is a flight by wire aircraft. It has the flight control computers. When you move in the air, the flight controls, you give an order command here in the primary flight control computers, as you can see in the overhead panel. You have in the auto position for flying, so you have primary flight control computers over here, as you can see. So this gives command to the flight control computers to make turns in flight, Z turns, like in the Airbus. You have the normal, the alternate, and the direct mode of the flight control computers. Also, the flight control computers control the horizontal trim stabilizer of the aircraft. As we fly, we can trim the horizontal tail of the aircraft using the control trim switch in the control wheel of the aircraft over here, or the alternate trim. So you have the manual trim switch channel of the flight control computers channels. Also, you have the alternate channel of the flight control computers channel. We have the auto trim, the automatic trim channel, the horizontal tail stabilizer for the Boeing 787. So you can see the horizontal tail here when we move up and down. Also, we have the trim switch here to balance the aircraft in flight. So you use either the auto trim function over here, automatic trim from the autopilot flight director system panel. If you have a failure of the hydraulic systems over here, it may affect the L2 or R2 hydraulic stabilizer system. You can see here which is controlled by the auto trim system, the automatic trim. You open this guarded switch from normal to cut off and disconnect the automatic trim, and you have only the alternate, the manual trim switch over here. So you can trim the nose up or nose down, as you can see, of the aircraft as you fly. So this is the alternate channel, nose up, nose down, like this. Or you use only the manual trim switch over here. As you can see, this is the manual trim switch here. Trim up the nose of the aircraft like this, trim down the nose of the aircraft like this. Pitch up actually the nose like this. This is the pitch up nose effect. This is the pitch down, and this is also trimming the horizontal tail elevator or stabilizer up and down. You can see also the flap limit speed. You can read here. You can read stabilizer, elevator. Elevator trim, left click down, right click up. So this is the elevator trim. We have the head up declutter over here, the switch over here, also head up declutter, and the autopilot disconnect over here. So this is the three switches in the control wheel, as you can see, of the Boeing 787. So we have, as I told you, the alternate pitch trim also. If we disconnect, this is for all Boeing 737, 747, 757, 767, 777, and Boeing 787 aircraft. If you have a failure of the hydraulics of the L2 horizontal, left horizontal, right horizontal stabilizer, you can disconnect either one or together from normal to cut off, and use only the manual trim channel of the flight control computers here. Nose up, nose down. So I will show you the rest of the flight controls. You can see both sides, as you can see. So I will show you a few more. I will show you one more view of the flight controls of the Boeing 787 900. Also the thrust levers. We have also the flaps and the slats, the speed brakes. I will show you how to control which are secondary flight controls, how to control the levers for the flaps and the speed brakes, the thrust levers, and this is all for the flight controls. So you will see now one more nicer view of the flight controls, and the size stick I use the Logitech Extreme 3D over here, as you can see, to control the flight controls. So you can see the Lszh Extreme 3D. You can see, I forgot to mention, we have the thrust levers over here. Move the thrust control like this, forward and aft. So you can see it's quite simple and easy. So I will show you now the other view of the flight controls of the Boeing 787, also the outside view. Then we go for the rest of the systems. Then we're gonna make a complete flight. In the end part of the video, you're gonna see the takeoff, climb, process, and approach and landing manual. So stay with me until the end part of the video. So I will show you now also. So this is a view of the flight control computers, of the flight control surfaces actually. So you can climb, you can descend, you can make turns in flight, right turns and left turns. So you can climb like this, you can descend. So this is how you control elevator up, elevator down. I hope you like the Lszh Extreme 3D, my side stick over here. You can leave neutral, you can use the horizontal trim stabilizer. Also the thrust levers over here. You can see the thrust levers over here moving forward or aft like this. So this is to control all the thrust levers only. Use full takeoff. So we have a few more controls over here. You can see also the outside view of the Boeing 787, also the flight controls. So we can climb, we can descend, make turns to the left, make turns to the right. So this is also the left and right turns. All together, turns, flight controls. So you can see the tail also. Hope you like it. So I think this is all for the flight controls lesson tonight. I will continue now with the rest of the cockpit system. So as you can see in the screen, we have the review like this. You can see the side stick deflection is proportional to the yoke deflection. Both sides move together, captain first officer. Very responsive control with all the trim stabilizer also. You can see we have here the flaps here position. You can position the flaps to the retract or extend position, how many degrees you need them to be up or down. So you can set like 18 to 80 30 degrees over here. Also the speed brakes, extend and retract. So you'll see here how many degrees you have set the flaps over here, like when you retract in the up position. You see the flaps moving up over here, just like in the handle position. So you see the flaps are retracted now. So you can set in the extend position also, fully extend over here. So now it's extending, as you can see, the flaps position. You can see the flaps are extending. You can see also the speed brakes over here. Extend and retract. So this is the speed brakes over here. Extend and retract. So a few more things to see before starting the flight management computer. So we have also the landing gear over here, as you can see, extend and retract. The alternate gear, you can see the gear position, down, up. Alternate gear, lock override, rejected takeoff, the auto brakes over here. Stabilizer trim, horizontal trim and rudder trim. Cabin altitude, rate of climb descent, outflow valves, gross weight for takeoff, differential pressure, you can go like 8 psi, and cabin altitude will be 8,000 feet when we cruise at 40,000 feet or higher. So we have a differential pressure, higher pressure inside, lower pressure outside. Total fuel on board and fuel temperature right now. Also the engines also indications. A couple more things to see, systems indications here. Systems display, you'll see later the displays here. So we have the flight management computer now, how to create the flight plan of the aircraft. So we input all the data of the aircraft for this flight, the takeoff, gross weight, that includes the empty weight plus the passenger plus the cargo plus the fuel on board, where the fuel is stored in the left and the right wing. In the center tank we have 30% in the left wing, 30% in the right wing, and 10% in the center tank. So the flight management computer is going to calculate automatically the loads from the cargo and the passengers, and the fuel on board is going to calculate the center of gravity of the aircraft from takeoff, climb, cruise, descent, approach, and landing. As we fly, the aircraft burns fuel, so the center of gravity is shifted all the time, is recalculated automatically every second. So it gives commands to the flight control computers also, and the autopilot and flight director system panel, the thrust levers, the engine thrust. So it controls all the things, the flight management computer and the flight control computers, the flight director, etc. So we have also the flight management computer calculates the center of gravity, the mean aerodynamic chord position, the Mach, which is 23% of the mean aerodynamic chord of the forward wing. So the total equal to maximum aerodynamic lift increasing forward wing. So the stall also will begin in flight. You have to monitor the stall speed all the time here when you fly. It's displayed just below your airspeed right now, your current airspeed. You will see a yellow and red indication, so you need to have an airspeed above the stall speed and an angle of attack that reduces the stall. So we have also the flaps we're gonna use for takeoff, 15 degrees of flaps. We have the horizontal stabilizer trim position, 4.25 degrees, and horizontal elevator also position. We have all these things. We're gonna have also um, the runway we're gonna use for takeoff and for landing. So we have the runway 14 in the Zurich International Airport, Lszh in Switzerland. So we have the runway length, the runway slope, the wind direction and speed, the barometric pressure, the density of the air, and the temperature of the air. The flight management computer is gonna give us. We have also the wind direction and speed. We have the runway conditions, if it is ice, dry or wet. The flight management computer is going to calculate automatically the takeoff speeds V1, V rotate and V2, like 140 knots. The V2. We have also 9 degrees of pitch attitude for rotation and takeoff with 15 degrees of flap. So we're going to have the takeoff. We have also the seats that are into the departure waypoints and fixes that include horizontal vertical navigation fixes and altitude and speed constraints for the initial departure and climb of the aircraft. We're gonna have the climb to the cruise level like 35, 36, 37, 29, 29, 30,000 feet above the sea level. We're gonna cruise like a few waypoints and make some turns in the air. You will see also that. Then we're gonna initiate the descent back to the airport elevation 7,000, 6,000 feet above the sea level. So we're gonna approach and land the aircraft. We're gonna have the stars, the starter terminal arrival, waypoints and fixes for the terminal approach and landing of the aircraft, as you can see. So we have the stars for the terminal approach and landing of the aircraft that include horizontal vertical navigation fixes, altitude and airspeed constraints. We're gonna help us align with the runway 14 International Airport in Switzerland. We're gonna have also the Lszh localizer, the instrument landing system of the airport, of the threshold runway, antennas that transmit the radio frequency of the localizer, and the glide slope which is received from the onboard airliners of the aircraft is going to be displayed in the primary flight display. So you see the horizontal localizer, the vertical glide slope. We're going to be aligned with the runway, heading magnetic north pole, heading on 136 degrees. So we will approach and landing. We're going to have the flaps extended to like 35-30 degrees, a pitch attitude of like 9 degrees or less for approach and landing with an airspeed 160-170 knots. Or 250-270 kilometers an hour, both for takeoff and for landing. So you will see also that we're gonna land with the runway 14, the landing gear extended. So we will have a complete flight plan or flight path or route for this flight. So I will use the flight management computer right now to input all the data I just saw you. So we go over here as I saw you in the flight management computer part. So we have a few more minutes left for these things. So we have the control. You can see the mouse pad again, this view of the cockpit. So you can see we have the modes here we can use, like identity, position, performance, takeoff, approach, navigation, data, flight plans, load, air traffic control, load plan, save plan, approach. So we have identity is the Boeing 787 900 model over here, the Iraq cycle, GNX engines. So we have the position, reference position, Lszh airport in Switzerland, the coordinates, GPS coordinates over here, inertial also reference. So we have performance for takeoff, takeoff performance. We use the gross weight for takeoff over here, zero fuel weight plus fuel on board, the reserves flight, cruise altitude, cost index, minimum fuel temperature freeze, and cruising altitude. So we'll start with the route first. Origin, departure and destination, Lszh also in Switzerland, and Lszh copy paste here in Switzerland. So we have clear that runway 14 over here. So we have the data, departure and arrival over here. We can set runway 10, 14, 16, 28, 32 over here for departure runways in the right side. And we have the seats in the left side that are arranged by departure waypoints and fixes with 2 alpha. So we use no trans for that. We have the arrivals, as you can see, departure arrival index. So this completes the flight plan. We have the approaches, VOM 16, VOM 28, 34 ILS over here, instrument line system 14 ILS 16, ILS 28, ILS 34, GLS 14, localizers 28, localizer 34. So we're gonna use ILS instrument landing system 14, runway Amity, Trans Amity, and the stars, the standard instrument departure, standard terminal arrival waypoints and fixes, Negria 1 Alpha. So we have the legs now completed. You can see the route is displayed with blue, so it's not yet active, and also it should be displayed with white and purple colors, so you can see one by one every waypoints after takeoff, the distance, airspeed and altitude we have to fly, also the heading. Here's a climb over here, as you can see, then descent approach over here, the stars, terminal arrival and landing. So we're going in the initialize again for completing the flight plan. So we have 322.7 thousand pounds plus fuel on board, 34,000, gross weight 355.9, reserve fuel 5% for this flight, cruising altitude 25,300 feet, cost index 100%. Over here, fuel freezing temperature in flight minus 37 degrees. Over here, and cruising center of gravity, so we will recirculate the fuel in flight so we won't freeze, as you can see. This cruising altitude, so this is the performance initialized. We have the legs here are activated almost. We need to press the execute button here, so this activate, you can see with white now and purple. So we have a few more things to see. You can see the first waypoint 136 degrees, heading 2 nautical miles, 250 knots, 1900 TRO, 1 nautical miles, then 3 nautical miles, 5 nautical miles, Zui, heading 056, 6 nautical miles, 300 knots, 6000 alpha. We keep climbing. This is the active route of flight plan or flight path. Nigria 300 knots, flight level 22,226 nautical miles from Zui, heading 072, Mativ 230 degrees, 12 nautical miles, 320 knots, 11,800, Amity 258 degrees, 6 nautical miles, 190 knots, 10,400, Zui 9 nautical miles, 187,000 alpha, Z8701, 186,000 alpha. We have the approach and landing, the stars over here, 290 heading, 10 nautical miles, 180 knots, 5,000 alpha, 235 degrees, 6 nautical miles from TRA, 180 knots, 4,000 alpha. Osnem heading, we make a turn, left turn here to align with the runway, 5 nautical miles, 170 knots, 4,000 alpha. Runway 14, 136 degrees, 8 nautical miles, 140 knots, 1,430 feet. So we have here also the flaps for takeoff. We use 15 degrees of flaps. The center of gravity is calculated automatically for takeoff. The horizontal trim stabilizer position for 0.85 degrees, and the takeoff speed V1, V-rotate, V2, gross weight for takeoff. So you have here also other functions you can see, like initialize, route, departure, alternate, VNAV. So we have alternate and VNAV, progress over here, FMC communications, hold the legs again, the fix, so we can hold in flight over a waypoint, or have a fix, and also have the navigation radio. We can tune the Lszh localizer here, so you can see the map now displayed here, the flight plan we're gonna use for this flight in the navigation display. So this is for navigation purposes. As you can see the flight plan we have created. You can see the vertical, how we're gonna be flying from climb, descent, approach and landing. Over here the vertical flight plan, how far above the ground we will be flying. Also the horizontal flight plan. You can see here the FIR airspace, as you can see. Center again, so maybe you see better the waypoints we're gonna be using over here. So this is the flight plan. Also we have the runway here, runway 14, taxiway from the GPS to the other runway. Also some mountains in front of you displayed with yellow, green or red color if they are further above you. So you can see the aircraft symbol here when we're gonna be flying. You can see also the taxiway here. We have the runway also displayed from the outside, and the terrain that we have. So you can see also the other display over here, the map setting over here, as you can see. So this is the flight plan from takeoff, the runway, climb, then cruise, descent, approach, and landing. We have a little bit more to see over here. So this is a cruise, make turn, then descent, approach, and landing. You can see also further away, more airports, or closer. This plan also with the terrain map over here. So you can see also a few more things. We need to do the autopilot flight director system panel here. So these displays are for navigation purposes. The pitot static, pitot dynamic, airspeed, GPS receivers all are controlled here from air data computer. As you can see, GPS receiver, airspeed, altitude, pitot static, pitot dynamic, magnetic north pole, laser gyroscopes. So we have also the autopilot flight director system panel, auto throw left and right, the airspeed we can set what we need to set for airspeed like this, for takeoff, autopilot engage, disengage like this. We have the LNAV and VNAV navigation, as you can see, flight director on off. Heading over here, we're gonna set the heading of the aircraft for takeoff, same like the runway heading guidance. Also altitude over here, set the altitude, barometric altitude that I saw you, 35,000, then hundreds over here. Also vertical speed over here, flight path angle, so you can descend. You will see you can use this cursor if you need to level off also, or climb. So I'm gonna climb like this. We have also the bank angle here in the heading, automatic or manual, automatic actually. So we're gonna see now autopilot flight director system panel displays over here as it should be. Also we have the engines display, left engine versus right engine. You can see the N1, which is the low speed starter shaft, low pressure compressor turbine of the turbofan engine, exhaust gas temperature per engine. N2, which is the high speed starter shaft, high pressure compressor turbine of the turbofan engine, 68.5% at idle position. Fuel flow per engine per hour, 1000 kilograms, 1000 pounds, oil pressure, oil temperature, quantity, vibration of the N2 stage of the engine. We have also the outflow position, the outflow valves from cabin pressurization. So all these things from the engine's functions are controlled by the FAREX. The engine's display, when you move the thrust levers, you give command of the FAREX. So we have the GNX engines on the Boeing 787-900 aircraft. Also have a gearbox installed with the FAREX. The FAREX are the dual channel redundancy. One channel fails, the other takes over. The full authority is electronic control computers, the control motors and display all the engine function and data you see in the upper and lower aircraft. Also fuel flow pressure from the 5th and the 9th stage pressurizer, which is used also for cabin pressurization, oxygen regulation in the cockpit, the PAX flow, air conditioning, ventilation, also for wing and engine at the ice, and for the hydraulic fluid tanks pressurization. So when you move the flight controls around, you have the hydraulic fluid tanks which admit pressurizer from the 5th and 9th stage of the engine. Also the FAREX control as we climb the aircraft higher into higher altitudes, like 20, 30, 40,000 feet above the sea level, like 9,000, 10,000, 11,000, 12,000 meters above the sea. As we climb higher, the pressure of the air, the density of the air, and the oxygen level become less than half than that of the sea level. Also, the aircraft will be flying with an airspeed rate like 2 or 3 times faster than that of the sea level. So we're gonna have a higher intake of air from the front fans. For combustion, fuel mixer is adjusted automatically from the FAREX, the fuel mixer. Also, as we descend back to the airport elevation. Also, as we climb fly higher, we have freezing temperature, -30, -40, -50, -60 degrees below zero. So we need to recirculate the fuel from the wing tanks and the center tanks into the engine components to heat up the fuel. This is also done from the Farex automatically. Recirculation of fuel and also oil and lubricant for not freezing in flight. So this is all the things we need to do. We have the overhead panel, APU, start. We need to start the engines left and right, IDZ, the great charge generator, battery over here, primary flight control computers over here, auto position, head air data computer, flight control surfaces over here, FT door, tank power, passenger oxygen, window heat over here, rammer turbine, hydraulics, left and right engine, driving hydraulics. As you can see, automatic position now is in the off, so we start again the engine driving and then to the auto position. So we have also the recorders, the cargo and APU fire over here, the electronic engine control for the engine, left and right, and the auto start, normal and ordinary mode. We can dump some fuel in flight to lose weight and select the nozzles and how much to remain. Left and right wing fuel tank over here, fuel booster pumps, center tank, also crossfeed valve with an tonic and feed either engine with either pump or either tank and balance the fuel between the left and right wing tank. So we have the fuel booster pumps, and also we have the wing and engine gun the ice over here. As you can see, the cabin pressurization, manual, also valves, automatic, we have to do nothing. Also we have the bleeder for the cabin pressurization, also for the other systems, and the air conditioning, oxygen, the pack system. So we need one last thing here to do before starting the engines, make the engine start demonstration. So also the digital display of all the systems here, digital format, as you can see. So we have the hydraulics here, IPU, oxygen, liquid cooling, electric, left and right engine, contactors, drive, APUs running, and the battery voltage 120 to 100 volts for 100 Hz frequency. So you can see the main battery 31 volts. We have also the hydraulics, where the hydraulic fluid goes, primary in demand, left and right engine driving, electric, and also 5100 psi the pressure and the quantity of the hydraulic fluid. Fuel, left and right wing tank, center tank, 11,000, total 33,000 pounds. Then high pressure fuel valves, left and right engine from the center tank. You can see the green lines. The crossfeed valve is off, you can turn it on, we can feed either engine with either pump or either tank. APU is running, use the DC motor. Also we have the minimum fuel temperature here, below which the fuel will freeze. Air pressurizer here, packs, doors are closed, cabin can be pressurized, landing gear, nozzle, brakes and temperatures, flight controls here, movement, as you can see, the tail, rather FS display, maintenance system, circuit breakers over here. So we have the checklist, also last thing to do before takeoff, normal menu. So we have the navigation display again. So we turn off both engines like this, fuel control to the off position. As you can see, you will see the off engine over here, indication, and systems going out. So you will see the engines going out right now. Hydraulics are off, so we need to restart the engines very quickly. Going here in the overhead panel, restart the auto start system. Both auto start, you will see the yellow reconfiguration here. You will see also we have pressurizer only, we have no fuel right now. So you can hear the roar from the engines. So we'll let both fuel valves, left and right, on. So we have the auto start on over here. both left and right engine auto start. So we are 34, 35. We need 1 more minute to go for flight. So we have 40%. You can see the messages are going off, and we have running engines over here, both with green color. Here we are, not running. So we use flaps for takeoff over here, parking brakes off, advance the thrust levers over here and going for the runway. We have taken the clearance from the air traffic control. So we align with the tiller here. So we advance the thrust levers to full takeoff power, as you can see. We have full takeoff power. Hold down the yoke until 100 knots, 80, 100 knots, 120, 130. We rotate over here. So we rotate slightly. It's up slightly, like 9 degrees. So we have the positive rate of climb over here. You can leave the yoke off, your hands off, and keep flying. If you need, you keep climbing. So landing gear up over here, as you can see. Keep climbing. So you see all the data you need. We are 1,700 feet above the ground, but 3,800, 500 above the sea, 2,400 above the ground, 3,900 above the sea. We climb with 5,000 feet per minute. The airspeed right now 168 knots. Pitch altitude 20 degrees over here. We lower. We have the stall speed here, the wind direction and speed, the vector. We can see the terrain around you, the flight plan. We have to fly all the waypoints, the engines, indication. So you can see how far above the ground we'll be flying right now. Over here we change the range. You can see the ground is below us with the terrain. We are like 4,000 feet above the ground. That is displayed with green here. As you can see, maybe better indication. So you can see also the head-up display. This is after takeoff. So we need to make the turn now to follow the flight plan over here. You can see the Switzerland beautiful view. So make the turn now as we climb. So we need to make a small turn now. You can see we leave the yoke off, the side stick off, and we can keep flying. There is no problem with the aircraft. It keeps flying on its own. Make a small turn here. So we have beautiful views here, as you can see. As we climbing here, over Switzerland, the lakes also, and the Swiss Alps. So hope you like this view of the aircraft. So we have 12 more minutes to come back for landing. As we climb, it's a nice view of the cockpit. You can monitor all the instruments. You can see the airspeed here. It's very close to the slow speed, but it's no problem for us. Keep climbing. You can increase also the rate of climb if we need. Make also a small turn over here, aligned with the flight plan. So we need a little bit more power. So we need to align with the flight plan here, as you can see. These lines. You can see the lakes here. The Germany, Bayern Munich, my homeland here. As you can see, the France in this side. The Italy back here, and the Switzerland, and the beautiful lakes. So we're gonna be flying higher, the Boeing 787, as you can see. We need to start the turn now to the airport, to our base. So this is the turn now for the airport approach. As you can see, we change direction over here. There is no problem for us to make this turn. So we have again the Germany here, and the lake of the Switzerland with the Swiss Alps. So make a little bit left, right rather right now. As we keep climbing. So we're leveling off here, as you can see, but keep climbing a little bit slightly more. We need a few more minutes for going back to the airport. You're gonna have the chemtrails in a couple of minutes. I have the stall symbol over here. I have no chemtrails right now. So we need to avoid the stall here and continue for the flight plan. So we initiate the descent now. We need to go back to the airport. This is a beautiful view over here over the lakes, as you can see. The galaxy also. Hope you like it. We had no chemtrails tonight, but it's okay. So we need to keep descending over here. We have 5 more minutes left for this flight. We need to idle thrust and increase the airspeed. So we have the manual descent right now for approach and landing over here. Have a nice view of the cockpit again. We are descending. Idle thrust and speed brakes. Descending. Make the turn here. So keep descending over here, as you can see, for approach and landing. And we have 3 more minutes, which is enough for the approach and landing with this aircraft right now. Use a little bit left rudder also for the turn here. So we use landing gear now, extend, also flaps for landing. So now we are approaching for the land of the aircraft, as you can see. So we have a few more clouds here as we are descending, and we have 1 more minute. You can use the Lszh localizer here for alignment, as you can see, when we have clouds. So we align with the runway. We have some side wind over here, wind gust, combatic wind gust in the side wind, as you can see. Align with the center line, and we have a few more seconds left for the approach and landing, because the video record will end in like 20 seconds from now. We have no more record, so I need to get faster for the touchdown here. So we are almost for the flare touchdown here. So here is the flare touchdown. As you can see, beautiful touchdown and flare, parking brakes, and thrust reverse. I'll thrust reverse here.